Let's do a Newton's second law problem. This one is problem 38 from chapter 7. So it says the coefficient of kinetic friction between a 2 kilogram block in the figure, the one that's on top of the table, and the table is 0.3. So what is the acceleration of the 2 kilogram block? So notice that that block is connected to a 3 kilogram on the right and a 1 kilogram block on the left. So the first thing that I'm going to do is assume a direction for the motion of the system. So I think that the 3 kilogram block is going to be able to pull everybody to the right. So I'm going to assume that the direction of the acceleration for each block is as given by the arrows. And the constraint equation for the system related to the fact that the string doesn't stretch or contract means that everybody has to accelerate with the same magnitude. So I'm going to call that magnitude of the acceleration for each block. I'm going to say that the magnitude is A. So A is going to be a positive number. All right. We know that there, from the figure, we see that there's two strings. One string is on the right-hand side. That's the string that connects the block 2 with the block 3. So the tension on that string, I'm going to call it T23. As we know from the material covered in this chapter, the tension along a rope is the same everywhere. We always assume in physics class that the ropes are massless. So that implies that the tension is the same everywhere. So the rope that is touching the 3 kilogram block is going to be pulling on that block upwards with the tension T23. And the part of the string that touches the 2 kilogram block is also going to be pulling on the 2 kilogram block with the same tension T23. There is an additional rope in the system, which is on the left-hand side, connecting the 2 with the 1 kilogram. So I'm going to call the tension on that rope T12. All right. So the next thing to do is write or draw the free body diagram for each one of the components of our system. So we're going to start with the 1 kilogram block. So the 1 kilogram block has a tension T12 pulling up. The weight of that block is pulling down. Nothing else is touching it. It's not touching the ground. It's not touching the table. So that's all the forces that we have. And I'm going to add to my free body diagram the fact that I know that the acceleration of this block should be in the y direction, and it should be positive with a magnitude A. The free body diagram for the 2 kilogram block, the one sitting on the table, has the normal force coming from the table going up, the weight of the block going down, the tension T23 pulling the block to the right, the tension T12 pulling the block to the left, and don't forget friction. We have friction with the table. That is a force going to the left because we're presuming that the 2 kilogram block is going to go to the right, so kinetic friction will be to the left. And I'm drawing also showing that the acceleration of this block is going to be to the right with a magnitude A. The third free body diagram here is going to be for the 3 kilogram block. So that one has tension T23 going up, the weight of the block, M3G, and the acceleration of this block is going to be downwards. So the y acceleration of this block is going to be minus A. The y acceleration of this block is going to be negative because I'm going to call the tension T23 going up, I'm going to call that a positive number. Therefore, the acceleration needs to be entered in Newton's second law as a negative number. I'll show you that in a second. All right, so we're ready for Newton's second law for these blocks. So going to the 1 kilogram block, we have tension 12 positive minus the weight equals M1 times A. AY is positive, so I leave it as A as a positive number. And we can put in the numbers. M1 is 1 kilogram, so 1 times 9.8 is 9.8. So we have T12 minus 9.8 equals 1 kilogram times A. So I'm going to call that equation number 1. Moving on to the 2 kilogram block. In the x direction, we have T23 positive minus T12 negative minus Fk. That's also a negative x component of the force of friction because it's pointing to the left. And the sum of the forces in the x direction should be equal to the mass of the system times the acceleration in the x direction, which is going to be positive A. One more thing to do here is to use the fact that kinetic friction is mu k times the normal, and the normal force is simple. You've done many problems like this. You can tell that the normal force, since the table is horizontal, the normal force is going to be m2g. So I'm going to replace, for Fk, I'm going to replace mu k m2g, and I can plug in some numbers here. Mu k is 0.3, m2 is 2, so 0.3 times 2 kilograms times 9.8 gives us 5.88, and the mass is 2 kilograms. So we have equation number 2 saying T23 minus T12 minus 5.88 equals 2A. All right, moving on to block number 3. Tension going up, T23, the weight of the block m3g going down, and the acceleration is downward. So Newton's second law says T23 minus m3g equals m3 times the acceleration in the y direction. But the acceleration in the y direction is negative. Therefore, I'm going to write it as minus a, because in these calculations, a stands for the magnitude of the acceleration of the blocks. It's a positive number. But the acceleration in the y direction of block number 3 is not positive, it is negative. So I type it in as minus a. So replacing the numbers and moving the 3 times 9.8 to the left hand side, I get T23 minus 29.4 equals minus 3 kilograms times a. So this, notice the tensions, where they show up, what tensions do we have and how they show up in the equation. So we have T12 in the first block, T23 minus T12, and then we have in the last block we have the tension T23. So what I'm going to do is try to construct out of equation 1 and 3, I'm going to try to get a T23, a term that looks like T23 minus T12, so that I can use that to cancel the T23 minus T12 from equation number 2. So what I'm going to do is take equation number 3 and subtract from equation number 3, I'm going to subtract equation number 1. So equation 3 minus 1. So I copy equation 3 again on the top, and then I'm going to copy equation number 1 but with a minus sign, and then I'm going to add them together. So equation number 1 with a minus sign, every term has been flipped, is minus T12 plus 9.8 equals minus 1 kilogram times A, and when we add them we get this, T23 minus T12 minus 19.6 equals minus 4 kilograms times A. So notice that we have now two equations that have T23 minus T12. So what I'm going to do is equation number 2 at the bottom center, I'm going to take that equation, I just copied it again, and I'm going to subtract from that equation, I'm going to subtract equation number 4. So multiplying equation number 4 by a minus sign, that flips the sign for everybody, and I'm going to add them together. So the purpose of doing this, of course, is to cancel the tensions. So T23 minus T12 cancels, and 19.6 minus 5.88 gives us 13.72, and 2 plus 4 is 6. And solving for the acceleration, we get the final answer that the acceleration is 2.3 meters per second square.